Okay, this video is about angles, specifically differences between degrees and radians as we move into the trigonometry unit. Okay, so angles and degrees. So first thing you need to know is the position of an angle on your quadrants. Okay, the initial side always goes from 0, 0 over to the right on the x-axis. That is always where your angles will start. Always, always, always. No matter if they're positive, they're negative, radians or not radians. They always start here, and the terminal side is where it ends. Okay, terminal meaning ending. So this is what we call the standard position of an angle. So if we're looking at, here's your 4 grids. Notice it makes a circle. We know a circle is 360 degrees. We call this the unit circle, and we will spend a ton of time with it as we get deeper into trig. But for now, let's just look at the unit circle with degrees. So starting at 0, 0, if I have an initial side of my angle, any angle here is between 0 and 90 degrees. Then it goes from 90 to 180. That's quadrant 2. 180 to 270. Notice the direction here is quadrant 3. And then quadrant 4 goes from 270 to 360 degrees. Okay, so notice your quadrants. And I want you to notice that it goes counterclockwise. The rotation is counterclockwise. All right? Those are positive angles. Counterclockwise is a positive angle. So you have to give a direction for your angles. Because if it's counterclockwise, it's positive. If it's clockwise, meaning going this direction, it is a negative angle. Okay, negative angle. So let's look at the same quadrants. Here's your angles in degrees, your normal positive angles, but let's go in the reverse direction. Okay, here's the initial side, here's my terminal side. Let's just pretend that's my terminal side. So, going counterclockwise. From 0, what is positive 270 is also known as negative 90 degrees. Keep going. Positive 180 is negative 180 degrees. Same place, it depends on the direction of your angle. Keep going. Positive 90 is negative 270 degrees. And keep going. This will be negative 360. So notice negative 360 and 0 are the same location, as is positive 360 if I was going the other direction. So you will learn these angles, you will learn these measurements, and know them very well as we move into trig. But today, your questions are really about locating the angles, whether positive or negative. So look at A. Where's the angle of 77 degrees? Look at the quadrants, look at the angle measurements. That is between 0 and 90, so it has to be in quadrant 1. Part B. Negative 48 degrees. So if it's negative, it has to be between 0 and negative 90, which means it's down in quadrant 4. 181 degrees. It's positive, so I'm going to go counterclockwise. And I know where 180 is, so 181 has to be just below that, which makes it in quadrant 3. Negative 110. All right, go to my negative chart. Negative 110 is going to be beyond negative 90, but not quite at negative 180, so that makes it in quadrant 3. Okay, so a lot of your questions today are just going to be locating your angle and naming the quadrant. All right, part B, angles and radians. Okay, first of all, you need to know what a radian is. The radian is the arc length of one radius. So here's your circle. Here's your radius. You're all familiar with the radius, right? If I could pick up that radius and lay it around the circumference of the circle, that length right there of one radius around the edge of the circle is what we call a radian. Okay? So if you look at a circle, here's my radius over here on the right. If I put it around the outside edge, there's one radius, there's 2, and there's 3. Okay, notice this is it's ending right in here. Just a little bit beyond where you think it would end. There's another one. So there's 1, 2, 3, 4, 5, and 6. Okay? 6, and it takes a little bit more than 6 to fill in this gap. Think about your quadrants. If you laid that right on top of this, okay, here's 0 degrees, there's 90 degrees, there's 180. So look at this. It takes 3 and a little bit more to get to 180. Notice 3 radians. Here's 1, here's 2, and 3. It really ends right here. However, it hits the axis right here, so it's a little bit more. Well, that's a common number that you already know, as if 3.14 radians it takes to get to 180 degrees. So we say that 180 degrees is the same as pi radians, because it takes 3.14 radians to get to 180 degrees. If you continue around the circle, it keeps going. Here's another radian, another one, and then you need a little smidge more, which means at 360 degrees, it took 2 pi's, because really that little extra is 6.28, which is the same as 2 pi's to get around. So to get to 180 degrees, it takes 1 pi. To get to 360 degrees, it takes 2 pi. Make sure you understand what a radian is, the length of the radius laid around the circumference of the circle. All right, so I just want you to look at these. So radians, we talked about radians. We talked about the fact that here's 0 and here's pi. We're going to go in the positive direction, okay? So if I go in the positive direction, I know this is pi, but this is splitting it in half. So this is pi over 2, half a pi. Go to full pi. Now I'm going to go here, and this is pi plus another half, which is 3 pi over 2. Continue on, and I have 2 pi's. Now, you're going to need to know radians in terms of pi, but you're also going to need to know it with numbers. So let's just break this down. We know the number pi is 3.14. Half of 3.14 is 1.57, so that's what pi over 2 is in radians. So if I continue on, I know that 2 pi's is 6.28 radians, and then 3.14 plus half a pi, save you the Greek, it's 4.71 radians. All right, so you need to be familiar about these locations of radians in numbers and radians with pi. Notice the direction's positive. Now let's do the same thing in a negative direction. We know this is 0. If I go in the negative direction, I'm going to end up at pi, but this time it's negative pi, which means right in between it is negative pi over 2. If I continue on another half a pi, that gives me 3 pi's over 2. Negative 3 pi over 2. And then I have negative 2 pi. All right, same values, this under's negative. So this is negative 1.57 radians. This is negative 3.14 radians, negative 4.71 radians, and then lastly negative 6.28 radians. So know them positive, know them negative. Okay. Once you know those 4 values, you just need to remember the direction when they're negative and when they're positive. These are figured out for you. These are going to be common angles you're going to see as we move into the unit circle. So just focus on what's comfortable. Look at your degrees, okay? We know this is 0, 45, 90, 135, 180. Hopefully the degree portion makes a lot of sense. So we already did 180, 270, 360. These angles are just in between. The circle broken up in fourths, basically. So if we know in radians that it's 0 radians here, and it's pi radians at 180, and we split that pi into 2, we get 2 pi. If I break this into fourths, let's think about this. I break it into fourths. Here's 1/4. Keep going this way. These are 2/4, which is also known as 1/2, right? So 1/2 a pi, 3/4 of a pi, and 4/4 of a pi, which makes 1 pi. If I continue on in fourths, there'd be 5/4, 6/4, which reduces to 3 pi over 2. Keep going, 7/4, and 8/4, which is the same as 2 pi. All right, so hopefully in the fourths it makes a little bit of sense. It's still the same values we already did. They just were reduced from a fourth being in a fourth. So here's 1/4. 45 degrees is the same as 1/4 of a pi. 3 pi over 4 is the same as 135 degrees. 5 pi over 4 is 225. And 7 pi over 4 is 315. I'll show you how to memorize this really quickly. I just want you to get the grasp of breaking it into fourths. So then we back away and we break the whole circle into thirds. Okay, if I go 0, break it into a third of 60 degrees. 1/3. Here's 180, right? If I break that 180 into 1/3, there's 60 degrees. That's 1/3 of pi. Here's 2/3 of pi, 3/3 of pi, which leaves us at pi. 4/3 of pi, 5/3 of pi, 6/3 of pi, which is the same as 2 pi. So it's following the same pattern. We're just breaking it into thirds. 1/3, 2/3, 3/3, 4/3, 5/3. Okay, look at this, re-look at this as you need to. All right, so to sketch the graph, now let's think about this. 3.75 radians. All right, we know in radians and numbers that over here is pi, which is a number is 3.14. Over here is This is 3 pi over 2 is 4.71 pi. 3.75 radians is between 3.14 and 4.71, is it not? So that means my angle has to be here. But remember where the initial side has to always line up right here? So make sure you do that. And since it's positive, you need to indicate the direction. It went in the positive direction. So draw your angle and indicate direction. It's very important. Now look at B, negative 4 pi. All right, let's think about this. It's negative. So if I go from 0 in the negative direction, this would be a negative pi. I need 4 of these, okay? If I keep going around, this is negative 2 pi, right? Well, here's my initial side of my angle, so I'm going to start here. And I'm going to go this direction because it is negative. So if I carry on, keep going, here's negative pi, negative 2 pi's, negative 3 pi's, negative 4 pi's. So guess what? The initial and the terminal side of my angle are in the same location, but notice the drawing, it showed that it went around twice, and it went around in the clockwise direction, which makes it negative. So part of your homework, you're going to be sketching graphs based on what they give you in radians, and just count your pi's as you need to. All right, for the whisk, I want you just to tell me what quadrant. Okay, for number 3, where is negative 1.75 radians? And number 4, where is 8 pi over 9 radians? What quadrant is your answer?